Glycolysis comes from the Greek stem word, the stem glyc, meaning sweet, and lysis means dissolution. So glycolysis is sweet dissolution. It's the dissolving of a sugar. Okay, glycolysis is glucose to pyruvate. It is the sequence of reactions that metabolizes one 6-carbon molecule of glucose to two 3-carbon molecules of pyruvate. 6 carbon molecules of glucose to 3-carbon molecules of pyruvate. It is an anaerobic process without oxygen that occurs in the cytosol. Now this is the whole overview of glycolysis. It looks a little bit intimidating right now, but I'm going to break this down in the next 2 slides into phase 1. This is phase 1 here. This is the investment phase. This is where it costs you 2 ATPs. And then on the second slide, I'm going to break this down into the payback phase, is where you'll gain 4 ATPs. So you will lose 2 and gain 4, so you'll have a net gain in glycolysis of 2 ATPs. And then you'll also get some nicotinamide adenine dinucleotide here be reduced. So let me, like I said, I'm going to break this down from here. Glucose will go into this fructose 1,6-bisphosphate, a 6-carbon molecule. And then from that, it will be split into 2. So that will be the second slide. So let's start with the glucose. And glucose is going to be phosphorylated. This enzyme, hexokinase. Now, kinases participate in phosphorylation. So hexokinase is going to phosphorylate. It's going to take one of ATP's phosphates and put it on this glucose molecule. And it'll put it on the 6 carbon. 1, 2, 3, 4, 5, 6 carbons. So here you have, now you have glucose 6-phosphate. This has been energized. Now we have, in the second step, and there's 10 steps in glycolysis. The second, and we look at these steps at the enzymes that help facilitate that reaction. So phosphoglucose isomerase, what this is going to do is just going to rearrange this 6-carbon cyclic hexose sugar into a pentose sugar, a 5-carbon cyclic pentose sugar. So basically what's going to happen is this first and second carbon are going to do a little rearrangement. So you'll have a 5-carbon cyclic structure, and then you'll have the 6th carbon coming off as a substituent. Then the third step is phosphofructokinase, another kinase, and it's going to cost an ATP here. Well, that will put on another phosphate, and that will become fructose 1,6-bisphosphate. So now you have a phosphate on number 1 carbon and on number 6 carbon. Now this is a very unstable molecule, and what's going to happen is we're going to have to split this in half. So aldolase will split this in half, and then you'll get 2 3-carbon molecules. And one of them is dihydroxyacetone phosphate, and the other one is glyceraldehyde 3-phosphate. Now glyceraldehyde 3-phosphate can go to pyruvate, but this dihydroxyacetone is unable to go to pyruvate. So we're going to have to change this around a little bit and make it another glyceraldehyde 3-phosphate. So everything at this point, now we'll use triphosphate isomerase to change this molecule around to get the second glyceraldehyde 3-phosphate. So everything now from this point is going to be doubled. We have 2 glyceraldehyde 3-phosphates coming in right here. So now we have 2 glyceraldehyde 3-phosphates, and everything will be doubled. So once we have an NAD come in, it's going to be doubled. Everything will be doubled from this point because we have 2 molecules we're working with, and the end result is going to be 2 molecules of pyruvate, a 3-carbon molecule. So here we have glyceraldehyde 3-phosphate. And the 6th step, this enzyme, glyceraldehyde 3-phosphate dehydrogenase, is going to take off some hydrogens. And it will take off those hydrogens. It will be this G3P, they call it short, glyceraldehyde 3-phosphate, it will be oxidized. And NAD, its oxidized form, will be reduced. And we'll also add a couple phosphates in there. And for each one of these, for each one of those, we'll add a phosphate to each one of these. And we'll end up with 1,3-bis phosphoglycerate. And the bis means 2 phosphates. So now we have 2 phosphates at 1 and the 3rd carbon. Now we're going to do a phosphoryl transfer with a phosphoglycerate kinase at step 7, we're going to take off one of these phosphates. And now this is where we start to get back some energy. So ADP will come in here and it will come out as ATP. We're taking off one of the phosphates here and gaining an ATP. Now step 8, phosphoglyceromutase, we're going to just rearrange this atom here. 2 of these, we're going to change the phosphate over to the second carbon. So it's just a mutation of this, and we'll move that carbon over. Now we have 2-phosphoglycerate, and then the 9th step, enolase, we're going to take out a molecule of water for each one, so that will be 2 molecules of water. And that way we are taking out a couple hydrogens and an oxygen, and that way we're ending up with a double bond. So now in step 10, that will leave us with phosphenylpyruvate. They shorten this for PEP, phosphenylpyruvate. Now for step 10, pyruvate kinase, another kinase, is going to do a phosphoryl transfer. And we're going to take this phosphate off of PEP, and now we will have pyruvate. So we gain another ATP at this point. So here we're gaining 2 ATPs for each molecule. So we have a total of 4 ATPs in this payback phase. And here, right after glyceraldehyde 3-phosphate, we're reducing NAD plus to NADH. So we'll have 2 of those. Now for every NADH, the electron transport chain, can make 3 ATPs. For every 1 NADH, we make 3 ATPs. And for every 1 FADH, we only make 2 ATPs. So with that being said, we have 2 molecules. The end result, we take a 6-carbon molecule of glucose, and our end result in glycolysis is 2 3-carbon molecules of pyruvate. And the net gain in glycolysis is 2 NADHs, 2 ATPs, 2 molecules of water, and 2 pyruvate molecules.